Good, how are you?
Good. How's your summer going? You doing anything fun?
Not really, just hanging out.
Yeah? Okay. Geometry's fun.
That's true.
No, it probably isn't that much fun. I was kind of joking. But
Yeah.
actually, of all of the different types of math, I really do not, I don't know. I used to say that geometry was my favorite part of the ACT and the SAT tests. And it might be. I don't know. All right, so we left off with number 6 on this page. So let's pick up with number 7. Again, we're still on triangles. So another question that is almost an algebra question. And they say x is equal to 2z, y is equal to 3z. How can I solve for z? Hold on one second while I change this. Okay. So if I go up here, let's make it easier. There's y, which is 3z, and there's x, which is 2z. What kind of an equation can you write now?
180 equals 5z.
5z equals 180, so z equals 36. And notice that they kind of fooled you by putting that there. It only confuses. I don't need that. I don't even care if that's z. You know what I'm saying? The only thing that's important on this problem is that that's 3z and that's 2z. I don't care what that is up there. It doesn't help solve the problem. I don't think they're intentionally trying to mislead, but it's, you're going to run into that a lot when you go to take your tests. What year are you going into, Cole? 10th or 11th? 10th? Okay. So it'll be a while before you take any ACT test.
Yeah.
So they want to know what is x in terms of y. Well, the solution to so many of these geometry problems is what kind of a formula can you write and then solve? In other words, what kind of an equation can you write based on the picture you're looking at?
I don't know.
Well, what's the sum of the three angles equal?
180.
So x plus y
plus 30
equals 180, which means x plus y equals 150, which means x is what in terms of y? In other words, I want the bottom to be x equals something.
All right.
So algebraically, what's the next step after that? And we will review algebra a little bit. We're not going to do all 4 hours in the summer on geometry. Only reason being is that when you take geometry, the first week or two, you're going to be reviewing algebra.
All right.
So how do I solve this for x? How do I get x all by itself?
Subtract the y.
Okay. So x is equal to what?
Negative y plus 150.
Yeah, or from the answers we're looking at, 150 minus y.
Okay.
Okay. Okay, let's go to another page. Fact. No, we're still on whatever level this is. I don't know if this is basic or intermediate. Okay, what equation can you write here?
4.5x equals 180.
What's the next step?
Divide by 4.5.
So what's the answer? Looking at the available answers. Uh-huh. Yeah, in other words, we'd probably do that on a calculator. It's 180 divided by 4.5, and that's 40. Okay, about number 9, what kind of an equation can we write?
Isn't that just the same, or?
Yeah, pretty much. Both of these problems are the same. In other words, that's frequently the name of the game in geometry. Is it doesn't matter what you're dealing with, whether it's triangles or angles or quadrilaterals. Your first step generally is to see what kind of an equation you can write.
All right.
So what's the equation? Just give me the equation. We don't have to necessarily come up with a solution.
2x plus 50 equals 180.
Yeah. Okay. Now this one a little different, not immediately putting it into an equation, but you still have to use algebra here. The ratio of the angles is 2 to 3 to 4. In other words, it might be 20, 30, and 40, only it can't be that, because that doesn't total 180. So what do I need to do here? This is a decent sized leap.
I don't know.
Need to introduce a variable. In other words, this angle, they're in a ratio of 2 to 3 to 4, but it's not 2, 3, and 4. It's 2x, 3x, 4x. That's a ratio of 2 to 3 to 4, because the x's are going to cancel when you put it up as a ratio. And now that I've introduced a variable, what kind of an equation can I write?
9x equals 180.
Uh-huh. All right, here they don't want you to solve for x and y, which we can't do anyway, but they want you to solve for the sum of x and y. The reason we can't come up with a specific x and y is, notice that if I tilt this I change x and y, but it's still 140. So I could come up with lots of configurations where this angle was still 140 degrees, but y and x would be different. However, every time I tilt that, y might get bigger, but x is going to get smaller. So the sum of x and y are the same. Now, this is a little more difficult to come up with the equation. Let's experiment. What can we figure out about this thing?
It's going to be larger than 180.
Well, can we figure out any of the angles?
No.
Yeah, we can figure out this one right here. What's that angle?
40.
Okay. And what do we know about this angle right there? Remember how that relates to x? If I called that z, I don't necessarily need to introduce a variable, but I will just to make it more understandable. What's the relationship between x and the two angles that it is not supplementary to?
Is it double?
It's equal. In other words, x is equal to 40 plus z. Something that's worth remembering. But that doesn't help us at the moment. What is z equal to? Regards to y.
90.
No, what is the relationship between y and z?
I don't know.
They're supplementary. In other words, whenever you have a straight line and you have another line that connects like that, angle 1 and angle 2 are supplementary. Always. Okay? That's one of the more important concepts in geometry. So that I can say z plus y is equal to 180. So z is equal to 180 minus y. Now, if I go back up into this equation and substitute for z, I get x equals 40. Instead of z, I'm going to put plus 180 minus y. Okay? So now at least I have an equation that is in x and y, and I've eliminated this variable angle that I introduced called z. I don't need it anymore. I'm going to be able to solve this question by manipulating this. So I've got this formula here. What's the next step to solve for x plus y?
I don't know.
Well, let's get rid of those parentheses. What do I have when I get rid of the parentheses?
40 plus 180 minus y.
Well, I can combine the 40 and the 180.
20.
Now, how am I going to solve for x plus y?
Add the y.
There you go. X plus y equals 220. No matter how I draw this thing, as long as I make that angle 140 degrees, then x plus y is going to always equal 220. Which is kind of interesting, because that means that that angle plus that angle plus that angle is always equal to 360. In other words, the sum of the exterior angles is always 360, regardless of whether it's a triangle or not. In other words, let's take a parallelogram, a four-sided figure. If I do this, 1 plus 2 plus 3 plus 4 always adds to 360. The sum of the exterior angles. If it was a 20-sided figure, still add to 360. One of those. That actually is an odd piece of information that is definitely worth remembering. Hold on 1 minute, Paul. I'll be right with you.
All right.
Hello? Yeah. Marty, can I call you back? Or do you know, are you going to come out and take a look? Let me check my calendar here. See, I think that might work. It might not. Yeah. If it's between 8 and 10, well, I got a doctor's appointment at 11. I'll see you Wednesday morning, Marty. Thank you. Bye-bye. Sorry about that, Cole. I just, hold on, let me make a note there. Got water leaking into my house, and he's the guy that's going to come out and fix it.
Cool.
So I didn't want to not take the call. Hold on a minute. Okay. Get back to this. All right, next page. All right, now we're doing intermediate stuff. Let's see how hard these are. Hello? Hello? All right. Cole, you still there?
Yep.
All right, let's take a look at this figure here. AD is parallel to BC. Even though it doesn't look like it in the drawing, it is, according to the problem. So, can we solve for x?
They're parallel them.
I'm going to draw...
Maybe supplementary.
Well, no, I'm going to draw just the parallel lines and one transversal. There's the two lines that are parallel. I'm thinking for a second here. We have two transversals. We have a transversal up here. That's a transversal. So what is this angle right here? It's x, right?
Yep.
In other words, so let's label it as x.
Oh.
In other words, that's what we're going to end up being able to solve, is that x right here. And then we will know that it's the same as this x. Okay, now let me draw another transversal, and we may have to use our parallel information. We may not. I don't think we do. In other words, this is 70, this is 60. What's this angle right there?
50.
What's this angle right here?
50.
So what is x?
70.
You got it. I don't think we've talked about one thing about triangles. Maybe we have. But the largest angle is always opposite the largest side. The smallest angle is always opposite the smallest side. The middle angle is always opposite the middle side. In other words, if I drew a triangle like this, and I labeled it 50, 60, 70, I could not have a side over here of 6 and a side down there of 6. It's impossible. If I have a side there of 6, then this side has to be a number less than 6, maybe 5. This has to be a number less than 5, maybe 4 or 3. But that single principle is a very important principle. Your largest side has to be opposite the largest angle. If you think about it, if I draw a triangle like that, clearly that's the biggest angle, and that's going to be the biggest side. All right, so if we look at this drawing here, let me duplicate the drawing. If this is x, and this is x, and this is 10, what other side has to also be 10?
The opposite of C.
Or AB.
AB.
Okay. And if this is x minus 15, a smaller angle than x, then AC has to be what?
-5 or?
Has to be less than 10. If you look at their various answers here. Now, as to whether x has to be greater than 50, well, is that true? Could x be as low as 50? If I made this 50 and this 50, well, this would have to be 35. That doesn't total 180. So, yes, x has to be greater than 50 also. There's no angle you can put in here that's less than 50 that's going to get the job done, because this angle over here has to be 15 degrees less than whatever x is. So this part is true. X has to be greater than 50. AC has to be less than 10, merely because it's opposite the smallest angle in the triangle. And AB does not have to be greater than 10. AB is equal exactly to 10. So it's 1 and 2 only. It's the general formula for the area of a triangle.
Base times height squared.
It's 1/2 base times height.
All right.
Okay? And let me tell you why. Now,
Oh.
this will help you to remember it. If I draw a rectangle, the area of the rectangle is what?
Base times height.
Okay? If I put a triangle in there, that splits the rectangle. So the triangle is 1/2 base times height. Now, it turns out that no matter how I draw that triangle, I can draw it like this. The area of the triangle is still exactly half of the rectangle. Or I can draw it like that, still half. No matter how I put my triangle in there, as long as the vertex is on the top of the rectangle, I've got half of the area of that rectangle. But the easiest way to remember it is to just draw a diagonal. And now clearly the area of the triangle is 1/2 base times height. Very important formula. One of those you want to lock out. Okay, so if we look at this picture here, the area is 6, So I can substitute that for A. And they're telling me that BC, the short side of this triangle, is 1/3 the length of AB. Well, notice that BC is the base, AB is the height. So I'm going to say the base is 1/3 the height. I'm just translating that middle sentence. If BC is 1/3 the length of AB, then the base is 1/3 the height. Now I have to solve this equation. How do I solve this equation?
Divide by 1, divide by 2. Or multiply by 2, sorry.
How can I get rid of my denominators in one step? You can multiply by 2. That'll be a two-step process. Now what? Multiply by 3. In other words, when you're solving equations, you want to get rid of the denominators almost always as a first step. Just turns it into a simpler problem. Well, I could have, instead of multiplying by 2 and then multiplying by 3, let's multiply by a common denominator so that in one step we get rid of the 2 and the 3. I'm going to multiply both sides by 6. Both these fractions disappear, and I get h squared. H times h is h squared. Now what?
Square root both sides.
So h is 6. What is the length of the hypotenuse of an isosceles right triangle of area 32? Well, let's draw a right triangle. The only isosceles right triangle has to look like this. In other words, an isosceles triangle has to have two equal sides. And a right triangle, the hypotenuse is always the longest side. So when you're talking an isosceles right triangle, it means the two short sides are the ones that are equal. That's the only way it can be. Okay? So I'm going to call this the base, and I'm going to call this the base. Normally I would call that the height, but because I know that that height is the same as the base, I'm going to do this. So now, what kind of formula can I write to solve for B?
Solve for B?
Well, they want the hypotenuse. But in order to get the hypotenuse, we're going to have to first solve for B. Because the only equation we don't have an equation that relates the area to the hypotenuse. We do have this equation. Times height, which is, we know, the same as B. So I'll be able to solve for B using this. The area is 32. What's the next step?
Times 2.
So 64 equals B squared. What's B equal?
8.
So that's 8, and that's 8. You got two ways to solve for the hypotenuse. The hard way, to me, is to use the Pythagorean Theorem. In other words, the hypotenuse is the square root of this squared plus this squared. That's certainly one way of doing it. But there's, to me, a much easier way by comparing it to the 45, 45. How do I know this is a 45, 45? Because these two angles have to be complementary and equal. So if I remember my 45, do you remember what the dimensions on this is?
Sorry, what?
What are the dimensions on my unit 45, 45 right triangle?
I'm sorry, I'm confused.
It's 1, 1, square root of 2.
Oh, okay.
Okay, so what we're going to do, instead of using the Pythagorean theorem to solve this, we're going to figure out, well, what's the similarity ratio, and what would the hypotenuse of this be? What's the similarity ratio?
1 square root 8. 8's
So what's the hypotenuse over here?
4?
It's
Or
8 times this.
oh, 8 times the square root of 2?
Yeah, 8 root 2.
Okay.
Which is one of the answers. But notice that to me, that's the easier way to solve it. And it's only easier if you have this memorized. But you want to get these memorized as quickly as you possibly can. This triangle and this triangle, which is a 30, 60, 90. When you have a 30, 60, 90, it's 1, square root of 3, and 2. Memorize both those pictures because you're going to, at least 100 times over the next 3 years, you're going to have to compare similar triangles to these two and figure out a dimension on the similar triangle. Now, we could have come up with the answer using the Pythagorean theorem. The Pythagorean theorem says the hypotenuse is equal to the square root of 8 squared plus 8 squared, which is the square root of 128, which is the square root of 2 times the square root of 64. Square root of 64 is 8, so you get 8 root 2. So you really want to be able to know how to do it both ways. Both of these skills are huge in geometry. If you learn only 2 things this whole summer, you want to learn how to use the Pythagorean theorem to solve for any side of a right triangle where they give you the other 2. And you want to be able to calculate sides of similar triangles. And in this problem, you can do it either way. But you want to be able to do it both ways. You want to know how to do it both ways. All right, that's a good stopping spot. I think we're going to be on to rectangles or quadrilaterals next. But I think I won't go into the advanced questions. I don't think that's appropriate at this point. But these are pretty good. So, Cole, I'll talk to you next Monday.
Talk to you next Monday.